So are we live?
Yeah. So, hello everyone. Welcome to Codeflow's DSA, and our today's topic is going to be bit manipulation and mathematics. So, our mentor for today is Jyoti ma'am, who is an MLH fellow and an education mentor at Girl Script Foundation. It's great to have you with us, ma'am.
Thank you so much, Pragya. And it was like the little chat we had before the start of the session was really great. And thanks for having me. It was really impromptu, but yeah, I was kind of nervous for this and I was kind of excited for this. So let's see what the session looks like. Hi, hello to everyone who all are saying hello in the chat. Just one second. So, how many people are there right now?
Let me just.
I can't see actually. I can't. Okay, so there are 67 actually. I just saw. So, shall we start?
Yeah.
Okay. So, I'll just turn off my camera and I'll just open my code editor so you guys can see what we are talking about and what we are going through. First, let me just share my screen and Praga, give me a heads up if you can see my screen, okay? Can you see my screen?
It's not visible as of now.
Can you see
Yeah,
it
it's
now?
visible now.
Okay. Just let me give me a heads up on this. My code editor, if you can see.
Yeah, we can see it. Good.
Okay, sure. So there is just, I'll just increase the font size so that it's better visible. So since the topic for today is bit manipulation and mathematics, so it's one of my favorite topics. And seriously, to be very honest, I hated computer science at first. Um, but these topics are what I learned first to do. These are the topics which I remember doing for the first time, and I was highly intimidated. But today we'll focus on starting from really scratch and then going above, just uh, doing what we have never done. So also have a document over here, as you can see the link over here. You can just I have posted a link. Here you can see a GitHub repo and you can just clone it if you wish. This repo is exactly what I have in my code editor right now, and whatever I write today, whatever code I write today, whatever notes I make today, you can just I'll just push it into the GitHub repo. You can just copy it from there. Also, it has diagrams to which you can just go and see. Okay, it totally depends on you. If you want to clone it, go ahead. And this is the link of the document. You might have your rights right now, and you can go and view the document. In this, there is a bit of question list. This is the first question list is mostly what we will be doing today. And the second half of this is just some more questions and just some more resources about learning mathematics and bit manipulation. And whatever we discover today, whatever we learn today, should be enough to land you a question, land you a good question. And you, for example, in Amazon, if you get a good question using Bitset, so you will be able to do that. So let us just start, and I'll just. So if you at any point of time you cannot hear me, just let me know. Okay. So let's go. So the first thing is converting a number to binary. Okay, so here is my C++ file which I'll be using for bit manipulation. And whatever I write, the code that I write in it, just let me increase the size so the people watching it on their phones can also view it properly, right? I hope you can just see my code editor. Okay, so what happens is how we convert a number to binary, that is really, really simple. So for example, if you have a number, just for example, in n is equal to 17, right? The primary language I'll be choosing today is C++, but if you are interested in any other language, so you can just let me know. Okay, so int n is equal to 7. So this is a number and I have to convert it into binary. Rough calculation says that 8 plus 4 plus 2 plus 1 uh, is how we calculate, right? We have 8421 rule, and just in front of this we have 16, 16, 8, 4, 2, 1. So 17 can be expressed as 16 plus 1, right? Which gives me 1, 0, 0, 0, 1. So this is how I write it directly. But what if I tell my computer to convert it just into uh, binary number, right? So as it is as simple as how we do in our code, sorry, in our real life. For example, when we are converting it a number from decimal to binary, we just divide it by two, keep on dividing by two, and from last to first, we just store the values, right? We divide the number by two, we store the remainder. So this is what I'm going to do. I'll just take an array. I can say it as 32 size maybe, or any other size you wish. If you are sure that it will fit into something less, you can just take it as 10, right? Then I'll just do, I need my number to be greater than 0, right? So while n should be greater than equal to greater than 0, I'll just store it at binary. I also need an index. I'm so sorry, I forgot that. Int I is equal to 0, and I just need something to be stored over here. So as we know, we store the remainder, right? We are storing the remainder that is divided by 2, and then we are decreasing n by 2. This is how we do on pen and paper, right? This is just simple translation from pen and paper to the code. And then I'll just do I plus plus. Now we have this binary array which has the number stored. Okay. This is what we do directly on pen and paper, right? This is nothing rocket science. I'm just starting with the very basics to just give you an idea. Even if you are a person who has never seen how to convert decimal to binary, this is the way how you convert it. You keep on dividing by 2, and at every iteration you just stored the remainder in an array at an index, and then you divide the number by 2, right? But now what my binary array would look like would be, it will be in reverse order. Okay, so I need to print it. Of course I need to print it, but from where I will start would be from reverse. So currently my array element is lying at, my last element is lying at I index because I did I plus plus. And from there to 0, I want to print my indexes. I want to print the values, right? Binary of k, not just endl, we want it in a single row. So okay, just let's try running it. Okay, works, right? We have 17, we have converted the code into uh, binary. So I hope this was just a very basic insight into how this all works, a very basic insight into how everything can be converted from decimal to binary. Okay, so the next thing that I want to cover up is bitwise operators. And over here, I'll be covering a concept called two's complement also. So, since I want the session to be interactive, I will ask you questions in between. So please make sure that you answer them. So let me just try bitwise operator. Bitwise operator.cpp. I'll create a new file. I'll just
Ma'am,
um, yeah,
a
tell me.
viewer is asking that can you let us know that why is that code in reverse, like the binary in reverse?
Okay, the code is in reverse because, okay, you guys tell me, when I'm dividing 17 is my first number. Let us just dry run it, okay? We have the number 17, and when 17 is divided by 2, the remainder, what is the remainder? It's 1, right? Then 17, then this line will execute, 17 will be half. What will be the half of 17? 17 would be 8, right? Then I have 8 by 2. What will be the remainder? It will be 0. Then I will have 8 by 2. I will have 4. 4 divided by 2 will give me 4 will give me the remainder as 0 itself, since it is even. Then 4 will be halved. Then 4 will give me 2 will give me the remainder as 0 again. And then since now my 2 divided by uh, 2 becomes 1, and 1 divided by 2 will give me remainder 1. Okay, so why it is reversed? The number over here is 17, since it is symmetric, so you're not able to see it. But let me change the number to 15 if I change the number. So you know the number in 15 can be 8421, that is 12. Again, it is symmetric. Let me just take a number which is not symmetric. Let me just take 10, okay? So it will be 1010, right? 10 should give me this answer. Now if I dry run 10, okay, let me just dry run for 10. What happens? Over here, n is equal to 10, right? It goes inside the array, binary array at index 1. That is binary at index 0. Right now I is 0. So binary array k 0 is indexed. What I'll have is n percentile 2. So binary of 0 should be n percentile 2. That is 10 divided by 2. That will give me answer 0, right? Now my 10 will become over here. My 10 becomes 5, right? And then I increases to I goes to 1 because I'm doing I plus plus. For the next iteration, binary of I is currently 1. Binary of 1 should be equal to n percentile 2. Right now, what is my n? As I told you, it is 5. 5 percentile 2 gives me 1. Then again, for the second try run, 5 divided by 2. 5 divided by 2 will give me 2, right? And then I plus plus, I becomes 2. And if I keep on continuing this, I can see binary of 2 will be given as 2 divided by 2, that will be 0, and binary of 3 would be 1, right? Because 1 divided by 2. As you can see, the numbers stored are, if we see it from left to right, if we see for array indexes from binary 0 to 3, if we are seeing the indexes from start to end, what we'll get is 0, 1, 0, 1, which is complete opposite of 10, right? So we are storing it opposite. If I would have started from binary arrays last index, I would have gotten a straight array. But you also know when we solve it in by hand, you know, right? We create a table and niche se upar we write, from bottom to up we write the elements. This is exactly what we have done. We are writing the elements over here using this array from bottom to up. I hope this is clear.
Yeah, ma'am.
Okay, so let's go and just see what are some of the operators. And since this time I want you all to answer whatever I am going to ask, I'm going to give you two numbers, and A and B, right? There are basically the number of operators I want you to do A and B, okay? Just we will see out it all together. A and B, and I want you all to just keep on. If you have, I highly recommend you should have your code editors right now. open in front of you and you keep on solving the code with me, because today, whatever I'm doing, it won't be just a theoretical part. We'll be writing code and we'll be understanding with the help of that. Okay. Uh, A XOR B, and cool. So these are three operators, and I also want you to find out this and this. And lastly, I want you all to find out negation of A. Okay. So I'm just giving you like 30 seconds. If you want to calculate, you can just go on. Okay. Otherwise, I'll just start. First of all, the first question that comes into my mind is what is the size of int and how many bits should I take to represent int while solving, while dry running this problem? How many bits should I take? I mean, 4, 16, 32, how many? Whatever is your answer, just write it in the chat. I'll be able to see it on my phone. 32 bits. Someone is saying 32 bits, someone is saying 4. I'm talking about bits, guys, not bytes. If you're talking about, asking bits. 32-bit is okay for normal operations. Okay, 64 is bigger. So this totally depends on your machine, you know. Just go into your code editor, even if you're not using it. You will just write size of int, right? For my system, for my computer, it's 4 bytes. Okay, 4 bytes. That means it will give me 16 bits, right? So my int will be represented as a 16-bit number. Does that make sense? In your machine, it can be 8. वैसे तो universally it's 4 bytes, but it sometimes the error comes. But for me, it's 4 bytes. Uh, it's 16 bits. Okay, I'm so sorry. 32 bits. I just calculated wrong. 32 bits, right? In my system, it's 32 bits. For those of you who wrote 32 bits, it's absolutely correct. And 4 bits would be really less. But for the sake of calculation, right now I'm using 4 bits. But in the last three, you will be seeing why I'm using 32 or 16 bits, whatever I use. So for the sake of simplicity, let me write A in the form of binary. What would be A in the form of binary? 101 makes sense, right? And what would be B in the form of binary? It will be 1001, right? That's no hard calculation. We just learned how to do binary conversion, and we just learned how to see it. Now, these are some of the logical operators. These are six bitwise operators. These are six bitwise operators which work on bit by bit basis. So, and first of all is on line 12, you can see I have done A and B. A and B means wherever you have, 0 and 1 is 0, 1 and 1 is 1, 0 and 0 is 1. Sorry, 0 and 0 is 0, right? So what would be A and B? A and B, for the first digit I'm comparing 0 and 1, it will give me 0. 1 and 0, it will again give me 0. Next again 0, next again 1. This is something very basic that we learn, right? This is something we are just able to remember. Then, what would be the answer of A or B? It would be just 1, 1, 0, 1. Makes sense, right? And then XOR. For XOR, if you don't remember the logic, guys, for XOR, it's just whenever you have 1, 1, jahan bhi number same aayega. Okay, someone is writing in the chat. Okay, 1, 1, 1, 0. Which one is the answer for this? Cool. So for XOR, whenever you have different numbers, Okay, there you will get 1. Whenever you have same numbers, you will get 0 as the answer. So just tell me A and B XOR 0, 1. We are comparing from a first element. We are comparing for the first digit 0 and 1. It is different, so hence my answer would be 1. 1 and 0, again my digits are different, so 1 XOR 0 would be 1. 0 and 0, my answer is the same because the two digits are same. 1, 1 will give me this, right? Now, left shift and right shift operators. So for here, can anybody tell me what would be the answer of line number 18? Like, please just spam the chat with your answers so that we see. I can't see the chat right now, I guess. Okay, so people are writing their answers, I guess. 18. Okay, cool. So a lot of you might think कि left shift होके bit discard हो जाएगा. This is nothing like that. B is represented in the form of 1001, but since you know इससे आगे भी there are 28 bits over here. There are 32 bits, right? So I'll just shift it one place and add 0 at the end. So if I shift it by one place, it will be 10010, right? I just shifted it one place. Just imagine it to be like this. I just shifted it one place and this becomes this, right? And similarly, if I right shift, 1001 would become simply 0100. Make sense? Because I'm just shifting it towards right. Okay. Now comes this part. A is 5. Makes sense. A is 5. That is in binary, it is 0101, right? Negation is basically not operator, we say it as. Negation is it reverses the bits, okay? On reversal of the bits, jahan pe 0 hoga, it will become 1, 1 will become 0, right? So what should be the answer? 1010. And if I wanted to print it, what should I get? Like in decimal, what should it give me the answer as? In decimal. So a lot of you might think that the answer will become 8 plus 2, which will be 10, but it won't happen like that. Okay. So what happens is, please make sure that you listen to this very carefully. In negation, you might have read in computer science that there are three ways to store negative numbers. First is your sign integer, second is your ones complement, second is your twos complement. So my laptop doesn't understand negative numbers concept. It uses second twos complement to compute this. So what we are getting actually, this 1010 is actually a twos complement of some number, right? It is actually twos complement of some number. So how it works, I'll tell you. For example, if it's, as I told you, it's 32 bits, I won't write all the 32 bits. I'll just use uh, just dot dot. So just let me tell you, if A is represented this, it will have 28 zeros in front of it, right? It will have 28 zeros in front of it. Now, when I reversed the bits, all of those 28 zeros would become ones, right? Make sense? All of those 28 zeros would become 1. Okay. Now my computer sees that, okay, this is a 32-bit number and the first digit over here is 1. Now my computer knows that since I'm storing it in the form of 2's complement and the number I'm getting has first digit as 1, that means it is a negative number. Remember, whenever there is 1 present at the first index, it is a negative number. It is a negative number. So my computer sees that, okay, this is 1. That means I have a negative sign in front of my number, but I still don't know what the number is. So now to compute the number, we can compute it. How a 2's complement is calculated? What is 2's complement formula? 2's complement formula is just 1's complement. 1's complement is nothing. 1's complement is when you reverse all the bits. मतलब एक तरीके से नॉट कर दो आप, ठीक है. वंस कॉम्प्लीमेंट, व्हेन यू डू वंस कॉम्प्लीमेंट, then just add 1 to it, you get 2's complement. Now, what the number I'm getting over here, which is this number, it's a 2's complement of some number. It is a 2's complement of some integer. I don't know that integer. So what I do, I again find out its 2's complement and I will get the number. Okay, it's reversible. So when I do 2's complement, all the all 2's complement के लिए क्या चाहिए मुझे? I need 1's complement. ठीक है, 1's complement निकालने के लिए I need to reverse all these bits. So my 28 ones will again be converted into zeros, right? 28 zeros. And then I have this 0101. These bits will also get reversed. So can I write it as, I'll just discard the zero. I'll just write it as 0101 for the sake of simplicity. Okay. And I'll just add 1 to it. What would be my answer after adding 1 to it? And what would be the answer in binary? Can anybody tell me the answer? Yes, 0110, which is 6 in decimal. So now my computer knows that my digit is 6 and negative number, it is a negative number. So I should get my answer as -6, right? Make sense? A lot of people don't understand why this negation happened, why this, I mean, why it is giving me the answer -6. It should be 10, but it shouldn't be 10, okay? And this is a really common question if somebody just asks you about it, and many people don't know that in computer it's 2's complement which is stored. Okay, so this is something you should know. And a lot of okay, makes sense. Fine. So this should give me, this is in decimal, this is 1, in decimal this is 13. Okay, in decimal this is 12. In decimal this is 18, and in decimal this is 4. Makes sense, right? Cool. So just let me push it into the repository. First of all, you can match the answers. See, I told you in my machine the size is 4 bytes. In every machine, mostly it is. Now I should get A and B as 1, as 13, as 12, as 18, as 4, and as -6. I hope this makes sense. Let me just push it at the repository, and then you can just see the changes over here if somebody wants to. If you want to see the code over there, running over there, if you want to run the code in your system itself. Okay. So the repository link itself I have uh, shared with you. Okay. Now we have done the first two things. Now the third thing, which is a really cool thing in C++, which I really like. For those of you who don't primarily code in C++, this is a really huge benefit that C++ offers us. Okay, that C++ has for us, which is the use of Bitset. So Bitset is similarly okay. How many of you know what is STL or what is vectors? What are the use of vectors in C++? Okay, basic knowledge. That's okay. So what I have is right now over here, for example, I have an array. So I have int arr 10. Is this the correct way? It is the correct way, right? Come on, guys. I know how to define an array in C++. Okay. So what happens is, this is an array. It will store the data type of int. Okay, works. What if I want to create a Boolean array? I have Boolean array and I have it as 10, right? I have the array as uh, 10 right now. I have the array of 10 integers and each 10 Boolean values. At every index of Boolean value will be stored, right? Make sense? Okay, right? Just one more thing I forgot to tell you, but wait, I'll tell you again. In this, I forgot to tell you about this over here. See, the thing is, you need to know how basic bitwise operators work because otherwise there are many algorithms which you won't be able to understand. Bit level manipulation you should know because otherwise you won't be able to understand a lot of things. Now for the left shift, okay, you notice something like my B is 9 and my answer after left shift gives me answer as 18. Is there any relation between 18 or 9? Can we create 18 from 9 or something like that? It's like basic maths, like 9 into 2 is equal to 18, right? 18 is equal to 9 into 2. That is right. So notice something very important over here. If I write x left shift y, okay, it means I have to multiply x with 2 to the power y. Okay, मतलब x जो भी नंबर है आपका उसको आप 2 to the power y में, x is your first operator, that is left shift के बगल वाला operator is your x, left shift के right वाला operator is your y. So what do you do is x into 2 to the power y. Okay, so over here what is x? In my question x is b, which is 9, and in my question y is equal to 1. So that means I need to do 9 into power of 2 comma 1, right? 2 comma 1 की power 2, 9 into 2, 18. Cool. And now it is no brain teaser now that if I have right shift operator, if I have a right shift operator, that means I am just writing it as x divided by power of 2 to the power by, right? That makes sense. So what you do next time, you don't have to just write in binary and you don't have to just like कि इधर उधर गया, just divide it by 2 to the power whatever it is, just multiply it by 2 to the power whatever it is, right? Okay, let's move to Bitset. So these are, of course, they cannot have same name. This is just for example. So can you tell me the size of a Boolean data type? What is the size of bool? What is the size of a Boolean data type? Size of bool. One one bit or byte. Please be very specific when you are answering. One bit or one byte? One byte, of course. The size of a Boolean, size of a Boolean variable, okay, it's one byte, and that is equal to 8 bits. Thick. Makes sense. Like this is normal thing that our college has taught us कि हाँ चलो एक byte में 8 bit होता है और एक boolean 8 bit का होता है. So what the property of bit set is, bit set is similar to a Boolean array. Bit set, simply consider bit set is an array of bools. Bit set is an array of Boolean values. Okay. right? Bitset is an array of Boolean values, and in this every हर एक इंडेक्स पे Boolean value ही होगी, but every bool value occupies only one bit, right? Like how cool is that? You are just decreasing the size by 1 by 8. Like ऐसे boolean की value is 8 bit, right? ऐसे the size of a boolean data type in C++ is 8 bits, but with this bit set we are able to store it in only 1 bit, right? Make sense? Now let us see how it performs. So some things that you need to keep in mind. Very important. A lot of beginners get confused, but please keep in mind. And why am I telling you to learn about Bitset? Because there are many questions you will see ahead. For example, we are going to discuss Brian Kernighan algorithm, and that can be solved with Bitset itself, and same complexity dega. Okay. So let us just see how you. So first of all, there are some points that you need to keep in mind. Okay. Bit set should have a specified size like arrays. Like in whenever we create an array, we have to specify the size, right? बाद में घटा बढ़ा नहीं सकते, right? So bit set should have a specified size. At the time of creation, it should have a specified size. Then bit set indexing starts from right. So for example, there is an array. Array में left to right indexing होती है, right? Leftmost index is 0 and rightmost index is n minus 1. Makes sense. But in bit set, the rightmost digit, the bit in bit set rightmost digit is आपका 0th index. Okay, makes sense to everybody. Now just let me tell you how we created. इतना बकवास करने के बाद. Okay. So for example, I want a bit set of 32 size. I want a bit set. This is the syntax. Okay. This creates a bit set for me of 32 size named B. Okay. Bit set is a keyword to create the bit set. 32 is the size and B is the name. Thick. Now, if I want to convert any number into, you know, I want to convert any number into bit set. Okay, I know how to create it. I know how to write it. But if I want to convert any number into a bit set, so for example, let me take any number int 20 maybe. Int x is equal to 20, right? And I can just write it as, this was just my syntax, and I can just write it as bit set, create a bit set of 32 size, the name should be 20, sorry, the name should be, and just create it this, right? Let me just reduce it to 16 because you won't be just able to see it. Okay. Now my bit set would look something like this. It will, if I just write it in 8 for the sake of simplicity, it would be just 0 0 0 0 842 1 0 0 1 0 1 0 0, right? Is this the boolean for 20? It is, right? So my bit set is storing. Okay. B is looking something like this. Okay, Vaibhav, question we have asked, why is Boolean variable 8 bits? So in C++, whenever we are storing Boolean values, it will just store extra data, which actually goes waste. Okay, so it is something inbuilt. Okay, so bitset में ये store हो जाएगा. Now you have to tell me. I'm asking bitset में indexing कैसे access करते हैं? Similarly as you do it in arrays. Tell me what would be b of 0, and tell me what would be b of 0 first actually. 0, right? We are starting it from this side. Tick. So B of 0 is 1. What would be B of 2? B of 0 is equal to 0. Yes, because we are starting from the right. And B of 2, right say 0, 1, 2. It will be 1. I'm sorry, this is my mistake. I wrote it. 1. Right? Makes sense. ठीक है. So now we have a basic idea of what Bitset is, how it is working, indexing क्या है, and boolean का size क्या है इसमें. ठीक है, what we are doing and what is happening over here. Okay. So similarly, if you want to set any index, if I want to store, if I have, I'll just comment it out. If I have some bit set and it has a size of this, it has this, and I want to set the bit at okay, by default, Abhi, I haven't stored anything in it. Okay, I haven't stored anything, so by default, let me just mention it over here. By default, the value of bitset is zero. Okay, अभी कुछ नहीं है तो अभी my b would look like this. Okay, now if I want to set b of 1 should be equal to 1. Now what my bitset would look like? B of 1 is equal to 1 and b of 5 is also equal to 1. We are just assigning the values like simple array. We can just assign the values to it. I'm sorry for this error over here. I just typed by mistake 1. It will be 0. You can just check it. Okay. After setting my b of 1 to 1, that means my this bit will be set as 1 and 5. 0, 1, 2, 3, 4, 5. Right? Makes sense. Okay, let me just tell you some really quick methods about Bitset. If you want, you can just write them or just run it in your code editor. फटाफट से. Okay. So I want to count the number of set bits. Count the number of set bits. In I'm just taking my number as bitset. I'm taking a new bitset num and the number inside it's 9. So my num will look something like 1001, right? How many bit sets are present? Let me just take it more. 11. Okay. How many set bits are present in this number? Okay. It totally depends on your size of bit set, whatever you want to take. Okay. So count the number of set bits. My set bits are 3. Set bit means जहाँ की value 1 होती है. So I have it 3. If I want to find out, just num.count. Okay. Num.count will give me the number. This is just a method. ठीक है. उसके बाद let's just see some more methods on bitset. फटाफट. And if I want the size of bitset, I don't know the size, so you can just do num.size. Cool. उसके बाद if I want to like If I want to check if at least at least one bit is set, one bit is set in my number, so I can just do num dot any. It will return true, I mean 1, in case at least one bit is set. It false if all the bits are unset. For example, in case of 0000, it will give me answer as false, and in case of 0001, it will give me true. Okay. Then, if no bit is set, no bit is set, right? I can just do num dot none. Okay. Num dot none will return true. Of course, the true I'm talking about is in case of a 0 and 1. Okay. Num dot none will give me true if no bit is set. That is in case of 0000, it will give me true. And in case of 0001, it will give me false. Over. Tick. This much is clear, I hope. Is it clear till now? Just drop me a yes or no in the chat if everything is clear right now. Amazing. Just one or two more methods which I want to tell you. One's complement अगर निकालना है, one's complement. Okay, one's complement is nothing but you just reverse the numbers, right? What you do is num dot flip, and it will give you the one's complement. Okay, and if you want if you want to set all the bits, means set all the bits in Bitset, then you just do num dot set. And if you want to unset all the bits, that means you want every bit set to 0, num dot reset. Cool. This was everything you need to know about Bitset and everything that you should know. Okay, Bitset is a widely popular data structure. I'm just pushing the code to the terminal. You can just try it running in your computers. You can just if you have cloned the repo, you can just go and pull the changes over there if you wish. Okay. Now let's go to Brian Kernighan algorithm. Okay. For this, we'll solve a question because question-based learning is the best thing. So a lot of I don't know if you guys do lead code or not, but on lead code you'll find a question like this. Mhm. So in the document itself, it is on the first number, this Brian Kernighan algorithm, comma bit set. Here is the link in the question document, which is on my GitHub repository. You can just go and check. Cool. It's over here. In the document itself, it is on the first page. ठीक है, पहला number है ये. You can just go and check over there. Cool. Let me just reset my code editor. I've solved this before. Okay. This is the question. You are given an integer n. You have to return answer, that is vector of length n plus 1, such that for each I 0 to 1, answer I is the number of ones in the binary representation of I. Okay. As you can see, many people have liked this since it is widely popular. This is a very famous question. This is, I guess, what we'll be discussing today is O of n, but this question has been asked in Amazon interview question in log of n. That algorithm is a bit tough. So after you have learned the basics of bit sets, you can bit manipulation. You can just go and attempt this question in log of n. Okay. So you have been given an integer, return an array. So what will be my first thought? So मेरे को 1 से लेके n तक के सारे numbers के set bits निकालने हैं. So what I can do is I have to loop over the array, get the vector. because of course I have to find I less than equal to n. Okay. For every number I have to find is the number of set bits. For example, if my n was, I'm just explaining it to you what question means. If my n is 5, so I first my n will become 1, then my n will become 2, then my n will become 3, then my n will become 4, then my n will become 5, okay, and then my loop will stop. So n is equal to 1. What is in it in binary? 0, 0, 0, 1. I'm just writing it in binary. 0, 0, 1, 0. Cool. Just open the link, guys, and lead code and try to solve it with me. Okay, because this is the best way you could practice. Just seeing the code won't help you. So 0, 1, 0, 1, right? Does this make sense? Does this make sense? Can you explain vector shortly? Yes, just let me explain this to you, then I'll just give a quick overview. Okay, okay. How many um, set bits are there in one? If I write set bits as a topic over here, set bits. How many set bits does the first number have? It has one, right? In second, it has one again. Then it has two. Then it has, what does it have? One, two, right? Is this making sense? Do you understand the question now? So what the question is asking me is कि मेरे को एक vector बनाना है and at every index I should have the number of set bits. So at 0th index of vector 1 का आंसर स्टोर होगा, at first index 2 का आंसर स्टोर होगा, at second index 3 का आंसर स्टोर होगा, and like that. Now when you have vector int, the people who are asking, vector is just a dynamic array. Okay, dynamic array means its size does not have to be specified by you. It can increase or decrease. Okay, so this is the way you create a vector, similar to something like Bitset, right? Whenever you are creating a Bitset, the only difference being that vector map, vector inside this you store the int data type. Matlab, you can have anything over here. You can have bool, you can have anything, string, anything you want. Okay, it's just a dynamic array whose size can be increased or decreased. Abhi vector has no elements in it, but if I do answer dot push back 5 or 10, my vector would have the first element as 10. Okay, right? Okay, makes sense. Now what my question is asking, it is asking me to loop from 0 to n. Okay, I'm looping from 0 to n. Makes sense. Then it should give me the number of ones. Okay. Now, can you tell me what method right now, what we learned in Bitset, what method can I use to count the number of set bits? I mean, the number of ones in a number. Dot count makes sense. So, inside this, I declare a bit set. Okay. Bit set usually 32 bits में आ जाएगा because you know int is of 4 bytes, that is 32 bits. That's why I have taken the size of bit set as 32. Bit set B, and I want my I to be changed into this. Okay, I'll just take a copy of I. Okay, I'll just take it over here, and now I just return b dot count, but I need to push it into the array, so answer dot push back b dot count. So what happens is I mera 0 हुआ. Okay, over here n will start from 0. I didn't see the constraint first, but anyways, n will become 0, then it will be converted into bit set, then the number of set bits in it will be pushed at answer. Then again the loop will continue till n, right? And now what is the return type of this function? Vector int. So since lead code pe you don't have to write the whole code, you just have to write the function, so you can just do it using that. Makes sense, it works, right? Okay, so but the second method that I can use over here, this was the first method. Okay, this was method 1 using bitset. Now if I use a second method is known as Brian Kernighan algorithm. Okay, I'm just commenting this out. Second method is known as Brian Kernighan algorithm. Now you need to just pay attention for something that I'm about to tell you. For example, if I have a number p and p is equal to 10, okay, what would be its binary representation? It would be 1010. What if I have, what if I do, I mean, just a second. I just store it, okay, and I just store p, I just do p is equal to p minus 1. P minus 1. Now what will be my p? It will be 9 and it will be in the form of 1001. Then again I do p is equal to p minus 1. Take. Now my p will become 8 and it will become, sorry, 8 and it will become 1000. And again p is equal to p minus 1. So can you notice something over here? Can you just what is the need of doing int k is equal to I? Okay, you tell me. What is the need of, why did I do this? Because something, for if I did it p of I, by chance if it changes the data of I and I has to be done plus plus, then my loop won't work, right? My, it is a good practice not to change or not to modify the loop variable, because since I have to do I plus plus also, right? I don't want i's value to be updated. That's why I used k. Okay. So let me just tell you the difference over here. Okay, what I'm about to say might sound a bit confusing at first, but hear me out. What I'm saying is, whenever I have a number p and I decrease p, okay, whenever I decrease p, just notice what I'm saying. If I have a number p and whenever I decrease p by 1, all the elements after the rightmost bit get reversed. The rightmost bit, set bit, and every bit after that gets reversed. For example, in 10, what is my rightmost bit? My rightmost bit is this one, right? The bit currently I'm processing, and every bit after that would be reversed. Currently it's 1, 1 would reverse to 0, and after 1 it will reverse to 1, right? I'm repeating it again. What I'm trying to say is, whenever I subtract 1 from a number, what I'm doing is every bit, including every bit after, every bit after the rightmost set bit gets reversed, right? Does that make sense? Okay. So just tell me, for example, if I know that P is given to me this, ठीक है? मेरे को नहीं पता P क्या है. I am given P is equal to 1000. I don't know what is P in decimal right now, but I know the rightmost bit. Rightmost bit is this, right? So I need to reverse rightmost bit. ठीक है? I need to reverse the rightmost bit. मतलब this will become 0. ठीक है? Makes sense to me. And उसके बाद के सारे elements, every element after this
Hello guys, I guess she's having some network issues, so she'll be back soon. Don't worry. Till then, you can post any doubts you have in the comment section, and she will be answering to them as soon as she's back. Yeah, there's some technical glitch. That's why the voice wasn't coming. She'll repeat that part. Don't worry. I hope everything is clear up till now. It's great that it's clear up till now.
Hi everyone, can you hear me? I
Hello.
just had some.
You're not audible again.
Okay, so I was saying that P is a number. I am not given its decimal representation. I'm given its binary representation. Now this number can be very large. Okay, it can be very large. So decimal निकालना बैठ के add करना, I don't know about it. Okay, I don't know zilch about it. So I know the rightmost bit is this. So I will reverse this, and after every bit after that one will be reversed. So this will give me the answer, right? 0111. And if I want to verify, so 1000 is actually this is 8 and 0111 is 7. My theory, my algorithm works, right? It works. So this is the first thing that you should remember about Brian Kernighan algorithm. That is, whenever one is subtracted from any number, every bit after the rightmost set bit is reversed. Okay. And the second thing that you need to remember about Brian Kernighan algorithm is that n and n minus 1 will remove the rightmost bit, will remove the rightmost set bit. Okay. So for example, let's just verify 7 and sorry 8 and 7. What should it give me? 8 and 7. 8 is 1 0 0 0 and 0 1 1 1. It will give me the answer as 0 0 0 0. Okay? My rightmost set bit is removed, right? I don't have any problem with removing rightmost bit. You don't need to care about other things. You just have to read, you just have to think about what are the two things that I have told you. Okay, whenever I decrease a number, every bit after the rightmost set bit will get reversed, and n minus 1 will remove the rightmost set bit. Makes sense. Is it making sense till now? It may be a bit tough to understand at first, but it is damn easy. Trust me, when you see the code, it will be just two lines of code, I guess, two or three. Okay. ठीक. उसके बाद, now what I'm trying to say is, when the number of times I do this, at every time I do this, one rightmost set bit gets reduced. It gets removed. So if I put a loop and count the number of time the loop runs, हर एक बार हर एक run में one rightmost set bit will get removed, and finally I will be left with no answer. Right? I will be left with nothing but zeros, and at that point the value of my count will give me the answer. See, what I'm trying to say is, I have this number n, int n is equal to 10, and while n means n is greater than 0, what I do is I do n and n minus 1, and I store it in n, and I do count plus plus, and int count is equal to 0. Does that make sense right now? It makes sense, right? See, this is as sophisticated as it gets. This is the only code that you need for blind Kernighan algorithm. It is just an algorithm. You know how algorithm is. It has a predefined set of rules. You know how it should work. In an interview, when they ask you, you have to count the number of set bits. Okay, it is not login, Mohit. I told you this method is not login. I told that there is another method that is login. This one is O of n. Makes sense, guys. Okay. So this is the only thing that you need to remember. Now I need to run my loop from 0 to n. That is, for 0 to n, for int I is equal to 0, I less than n plus 1, I plus plus, and for every number I will count, right? उसके बाद I'll just push back it into my vector. If you don't know vectors, guys, I highly recommend you should read about vectors, because come on, without vectors I don't know C++ is any powerful tool. So this is the only thing that you need to remember about Brian Kernighan algorithm. This is just a set of ideas. Okay. Sorry, I did something wrong. It might be n. Okay, sure. It might be less than n. Please do some idea to do it in log n. Log n is I I can give you an idea, but again the thing is that it won't be feasible for you to just jump from beginners to that algorithm. But yes, of course, if you are excited, you can just go on Geeks for Geeks and just learn about it. Okay. So these are two questions which I want you all to just attempt today. It is in the sheet itself. Where is the sheet? This. The second and third question. Okay. Just let us run this. Since I need an alias to store this. I need to change it to I. I always forget to change it to I. I don't know why. What is happening then? I. Oh god, that is so stupid. There is some error in this code. Just let us see this. Okay, makes sense. It was just a syntax error. Okay, makes sense. You can see, and I'll just copy paste this code itself and over here. So you have grind cpp. I'll just paste the code over here, okay, so that you can see it for reference later. It is not a complete code, it is just a part of the function. Cool. So these are the two questions that I want you to attempt because, come on. Okay. Now let's dive into maths. For maths, first let me just take your doubts for bit manipulation. If you have any, just drop it in the comment section. I'll just read it. Any questions, you can just pop up.
There was a question earlier which said that to XOR of all numbers, the number occurring odd number of
Okay,
times will be the answer.
this one, they are answering this, but I think so they should do it on their own. Can you tell minus a? Okay, I won't be able to tell it again, but just see it over here. Where did I put it? I put it in Bitwise, I guess. This one. I'm just saying when a number stores a negative number, it is similar to 2's complement, okay? So I'll just find out 2's complement again, and whatever it will be my answer, okay? What STL library is? Dude, you can just write this thing at the top of your code and you don't need to include any library. Where can I get your code? You can just go to GitHub. The link has been shared in the chat itself. You can go fork that repo. Okay. The link is there itself. And you can just see this is the link. This is the repository. Mohit, num.count will give all the set bits. I don't think so. There is anything to find contiguous set bit count. Okay, so you just have to run algorithms for that. So you can just get the repository over here. You can just go over there. There is an option to fork. over here. This is fork. You can just fork it and get it for your own GitHub account itself. Okay. Are vectors similar to array list in Java? I don't have any idea about Java because I don't use Java at all. I have never used Java to be very honest. Okay, so let's dive into maths and maths में ज़्यादातर we won't code. You will understand theory क्योंकि if you're doing competitive programming and anything like that, maths is required a lot. In bit manipulation, is there any more concept? So over here, you'll when you go to questions. Over here, this is a link, bitwise tricks. Here you will see some tricks which are not actually explainable, but these are just a little like tricks, how you can do it, what how you can find whether a number is a power of two or not, something like that. You can just go over there and see the tricks. Okay, so let's start with maths now. Okay, I'll be really quick in LCM and GCD because this is something uh, everyone should know. Okay, uh, GCD and LCM. First of all, let me have an idea how many of you don't know LCM or GCD. Like, is there a need to tell LCM and GCD? Because I think everyone knows what LCM and GCD is. GCD is just highest common factor. That is, you find if you want to find the GCD of two numbers, then you just find out their prime factors and take the intersection of both. And if you want LCM, for those of you who are asking the link sheet, when you go to my GitHub repo, ठीक है, उसमें सामने ही in the it's written over here. The link is in front of you in my GitHub repo. Okay, so we are not covering LCM GCD because a lot of people might know about this. If not, because this is something we have been taught in school, right? First, let us read Catalan numbers, then we will read C. Okay, because Catalan numbers are more important. So I'll just open it in my Catalan numbers. Okay. So Catalan numbers is a topic that many people struggle with. But because Catalan numbers का code बहुत easy है. Everything is easy. Okay. Catalan numbers में कुछ इतना खास भी नहीं है. But when you're given a question, ठीक है? When you're given a question, it's very hard to identify कि वो Catalan numbers का होगा. You are not able to identify कि वो किस जगह का है, कहाँ का है. So Catalan numbers are a great category of questions, but again, the thing is that people don't know how to use or what pattern should they use कि Catalan numbers कहाँ use होता है, कैसे use होता है. So we'll just learn about that. Okay. Okay. So Catalan numbers is just a series like this. Okay. Catalan numbers like any other series APGP की तरह बस एक series है. Okay. So for example, if I have to find Catalan number of n is equal to Catalan number of 0 into Catalan number of n minus 1 plus Catalan number of 2 into Catalan number n minus 2 plus Catalan number of मतलब end तक चलता रहेगा सीरीज जब तक c of n minus 1 c of 0 तक नहीं पहुंच जाते. ठीक है. C is just a representation. ठीक है. C is just used to represent the Catalan number. So for example, if I'm doing if in any series I need to get starting element, right? So Catalan number mein C of 0 is always 1 and C of 1 is 1. So can you find out the Catalan number of 2? Can you give me the Catalan number of 2? क्या हो जाएगा? Catalan number of 2 should be C of 0 and C of 1 plus what? C of C of it's 1, okay? You know that, of course, you know that, you're smart. C of 1 and C of n minus 2, that is C of 0. So what should be the answer? C of 0, you know it is 1. C of 1, you know it is 1. Okay, this is 1, guys. The series printed was wrong. It is C0, Cn minus 1 plus C1 n minus 2. Just increase 1 from the first number and decrease 1. Okay. What is the use of Catalan numbers? That only I'm going to tell after that. Okay. C0, C1, that is 1 plus, yeah, okay, 2. So Catalan number of 2 is 2. Can you find Catalan number of 3? Catalan number of 3, can you quickly just find it out and give it to me? Catalan number 2 will be C0, C1 plus C1, C0. Okay, Catalan number of 3 would be 5. Any doubt till now? Abhi tak any doubt you have? You know it is Catalan number is a series C0, Cn minus 1 plus C1 n minus Cn minus 2 up till Cn minus 1 C0. This is just a series. उसका first digit दिया है like Fibonacci में दिया होता है. उसका second digit भी दिया है. I mean C0 and C1 is given to you. उसके बाद you can draw the series yourself, right? So just remember this. Some C2 2 होता है and C3 is your 5. Okay, I understand now what capital number is. I understand whatever this is happening. I just don't understand how we will be using this. Okay, I mean, what sense does it make? कि मुझे पता है Catalan number का series क्या होता है मुझे पता है and the code is very easy to make, right? You just have to take the numbers and you can just go ahead. Okay, makes sense. So now Catalan numbers is used in a lot of areas. So for example, a if I ask you to draw a BST, binary search tree, you know what is a binary search tree. For those of you who don't know, नोड के लेफ्ट में उससे कम वैल्यूज होती हैं, हर नोड के राइट में उससे बड़ी वैल्यूज होती हैं. आई होप यू नो दिस मच, राइट? Binary search tree. So if I ask you to compute binary search tree, कितने बाइनरी सर्च ट्री पॉसिबल है n नोड्स के लिए? ठीक है, if I ask you to tell me. So for n is equal to 1, for n is equal to 1, n is equal to 1, that means I have just a single node. So there is just one binary tree possible, right? Just one BST possible. Makes sense? The question is the number of ways you can create a binary search tree with n nodes. If I have been given n is equal to 1, there is just one way I can create a binary search tree by creating only one node. If I have n is equal to 0, I have no node. How many ways? Still one way. Still one way. Why? Because I create no tree. I'm asking the ways, okay? I'm not asking the number of trees, I'm asking the ways, okay? So if I'm giving n nodes, n is equal to 2. Now comes the picture, like we are going to discuss about how Catalan numbers fit over here. Now if I'm going to do n is equal to 2, check. I have a and b, n is equal to 2 ka matlab I have two nodes, one is a and another is b. So the relationship between them is a is less than b. So as you know, binary search tree में left वाला side छोटा element होता है, right वाला side बड़ा element होता है, right? So a will always be to the left of b, right? Makes sense. So the first tree which I can create is this one. I can create a node a, I can create b, and since a is smaller than b, it will be on the left side of b. And I can create this. If I take a as the root, I can just put b at right because b is greater than a. Makes sense to everybody till now. Does it make sense? Cool. Okay. Now, if I have three nodes, what will I do? What I can do is I'm given three elements A, B, C. The relationship is this, that A is less than B, less than C. The first choice is this, right? I can take B as the center node and A is a smaller, तो वो left में आएगा, C is greater than, तो वो right में आएगा. First choice is this, right? Now, if I change it and take A as the root, तो A अगर root है, तो B will always come to its right because B is greater than A, right? Can you see all the five diagrams and can you see how it is working actually? Is any more combination of nodes possible? Is any more combination possible right now for this set of nodes, for these three nodes? Can you create a new tree out of, apart from these trees? No, okay. C is greater than B, then C should also come in right then. I'm just telling you ways because, okay, this is just numbered wrongly. It's C and B. Okay. Apart from this, any more possible combination is not possible, right? Okay. So what is happening right now is you can see the pattern that we are going to create. The pattern that we are creating for creation of the number of ways a binary search tree should be created. The pattern is of Catalan numbers. Okay. If somebody asks you what is the number of ways for n is equal to 4, can you tell me n is equal to 4 ka answer? You don't have to draw the trees. You just have to tell me the number of ways a binary search tree can be created with four nodes. Can you tell me what the answer should be? For n is equal to 4, you have to just draw the Catalan number wala. You have to just draw कि कितने Catalan numbers आएंगे कैसे. N is equal to 4 के लिए what will be the series? What will be the series? Can you just quickly write in the chat the series? What would be the answer for it? Yes, fourth Catalan number. It would look something like C0, C3. Let me just write it for you. It will look something like C0 and C3 plus C1 and C2, right? Plus C2, C1 plus C3, C0, right? What will be the answer of this? Since you know C0 is 1, this C3 is 5, so this will give me 5. Then I have C1, C2, that will give me 2, this will also give me 2, 9, and 9 plus 5, 14. So the answer should be 14, right? Makes sense. Okay. Now there is a shorter way to do this also. मतलब अब अगर मुझसे कोई पूछे ना that the number of ways the binary search tree should be created with n nodes, you don't have to create binary trees क्योंकि possible ही नहीं होगा. For n is equal to 6, for n is equal to 7, you won't be able to create binary trees. ठीक है. You can't create how many binary trees are there. You just find the number of Catalan number. You just find the nth Catalan number. So now you see how it fits into it. Okay. Now also there is another way to do this. Let me just take an example of, let me take it as n is equal to 3 itself. Okay. I'm just writing it over here itself. N is equal to 3 here. Okay. Just see what I'm doing over here. Okay. Just don't get confused whatever I'm doing. Just see what I'm trying to do. Over here I have a node. How do we know it's question of Catalan numbers? I'm telling you the uses. It is actually you won't have to go into proof or something like that. But we know it is the application of Catalan numbers. Okay. So n is equal to 3. I'm fixing the root as A, B, and C. So this is just another way to visualize Catalan numbers. If you see this, if you see how it is working, you will just realize it. Okay. Now A is equal to 0 है. Sorry, A is पहला node है. तो A के left में कितने nodes हो सकते हैं? How many nodes can A have to its left? If there are 3 nodes and the relationship is A is less than B less than C, how many nodes can A have on its left? None. Okay. So here you have 0 nodes. 0 nodes. Okay. How many nodes are possible on the right side? कितने nodes आ सकते हैं? 2 nodes, right? Amazing. Now if B is the root node, कितने left में आ सकते हैं? कितने nodes B के left में आ सकते हैं? This is a separate tree, okay? I'm fixing the root as B. How many nodes can come to the left of B? 1 node, right? And how many to the right of B? 1 node. I'm not creating a tree. I'm not drawing anything. I'm just thinking कि हाँ B से छोटा एक एलिमेंट है, B से बड़ा एक एलिमेंट है, तो एक नोड लेफ्ट में आएगा B के, एक नोड राइट में आएगा B. Just now, can you tell me the number of nodes to the left of C? 2 nodes, right? And over here I will have 0 nodes, right? Now can you see something? What you have to do? Nothing. No brain teaser over here. Nothing over here. जो भी है नंबर लेफ्ट और राइट में जो नंबर आ रहा है जस्ट राइट इट. C0 into C2, right? Plus, since it is a different tree, you just write C1 and C1 multiply. Plus, since it is a different tree, 2 nodes हैं यहाँ पे, तो C2 into C0. Can you tell me ये C किस चीज की सीरीज बन रही है? If you see it, can you tell me कौन से Catalan number की सीरीज बन रही है? Which Catalan number is this? It's C of 3, right? It's the series for C of 3, right? Amazing. So now you know बिना tree बनाए how you can find out कि कितने possible combinations हैं. So this is just a use of Catalan number, how Catalan number fits into this, ठीक है? How Catalan number is going to work like this. So what you need to do today is just go over the internet, ठीक है? Search for uses of Catalan numbers. उसमें 10-15 question आएंगे. There would be many questions, and most of them would be simply nth Catalan numbers. And in exam, whenever you get a question like this, is a very popular question, that can you find the number of ways I can create B, find the search tree if I'm given n nodes. So many people don't know how to do this. हर कोई combination permutation लगाने बैठ जाता है या they start to manually count it. But this is directly an answer of nth Catalan number. It is just a for do. ठीक है? Let me discuss one more application of nth Catalan numbers with you, which is this disjoint chords. Okay. So the question looks something like this. My question is that cool. My question is that you are given even number of points. The keyword over here is even. Okay. You are given even number of points on a circle. The points can be like 2 points, 4 points, 6 points, but even ही होंगे हमेशा. ठीक है? They are going to be evenly distributed. And for every pair, you have to find a number of ways in which chords can be created such that chords do not intersect. Find a way how many pairs of points exist such that chords do not intersect. For example, n is equal to 1 means a pair. Now, please keep in mind, I'm not talking about one point, I'm talking about one pair. I'm talking about one pair, okay? This is a pair. Orange dots represent the points. Okay? One represents a pair, not one point, a pair of points, okay? Fine. So for n is equal to 2, I have these two answers. Now you might think ऐसे क्यों नहीं ज्वाइन किया? ऐसे ज्वाइन करते तो दूसरे नंबर्स को ऐसे ज्वाइन करना पड़ता ना, तो they would have intersected. So this is not we want. We want non-intersecting chords. Does that make sense? Is this question clear to you? Is this question clear to you? Okay. So ये ठीक है disjoint chords है okay okay the question looks really tough कि I have to find a number of ways in which I can divide a circle into some sections in which the chords shouldn't intersect, right? But how? I mean, I can see it working. Means both of them will be some same distance apart. It isn't necessary. Let me show you for n is equal to 3. ठीक है, n is equal to 3 के लिए I am showing you एक पेयर ये बन सकता है, ठीक है? This can be one way, 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 this can be one way. In this way I can divide, right? Chords should not touch. Okay. And I have just given one example of a chord, okay? Now, uh, let me show that to you कि ये होगा कैसे. ठीक है? For one pair, you know there is just one way. So, you know for one pair it is one way. For two, the answer is two. Why? Because I have this, I have this. So what we do now is that I can see it on my screen. ठीक है, 2 के लिए बन रहा है ऐसा circle बन रहा है, 3 के लिए 5 बन रहा है. So does it ring a bell? Which uh, series gives me actually n is equal to 1, n is equal to 2, and 3 के लिए 5 आंसर आ रहा है, 2 के लिए 2 आंसर आ रहा है, 1 के लिए 1 आंसर आ रहा है. Which series gives me that? AP doesn't give me it. AP won't give me this answer. For this question, let me again repeat it to you. सिर्फ n is equal to 3 के लिए focus करो. If I frame my question like this, that for you have to draw a chord in a circle such that you divide the circle into two, that is एक side पे even numbers, दूसरे side पे भी even dots. मतलब if I'm doing this, I have two over here, two over there, two over here, two over there, two over here, one on each side, one pair on each side. Okay, so this is just another application of Catalan numbers. कि ये होता कैसे है, ठीक है? How is it done and how is it created? Okay, so if anybody asks you, you don't have to be like, I don't know this question, I don't know about this. You just have to write the nth Catalan number. That's it. So if you want to see the code of Catalan number, just go on. First of all, try it yourself because Catalan numbers code is really easy. You don't have to do it anything. एक Fibonacci की तरह बनता है. Not like you just have one, you just have C of one, you just have C of zero, and then you keep on expanding. Okay. Next, we have just two big things that I need to discuss. That is Sieve and Russian peasant algorithm. Okay. So, Russian peasant algorithm is not that important, but a lot of people do prefer asking it. Okay. Russian peasant algorithm, I think I won't be able to take up due to time constraint, but let us learn sieve. Okay, कि sieve क्या है? Okay, I have this and I should have it over here too. I have this over here. Okay, finally, we are about to study a really popular topic in mathematics. So sieve का काम क्या है? First of all, you might have seen at your home also, you might have a sieve, छलनी कहते हैं जिसको हिंदी में. That is used to filter something out, right? And whatever is left, for example, if you have something, for example, if you have some food जिसमें कुछ गंदगी है anything, you just use your sieve to clean it, and जो भी ऊपर बचता है, you just throw it away, and you have a clean food, right? The idea is same. You are going to discard some parts and you are going to keep some parts. You are going to filter out. Okay. So for example, if I have a number uh, n is equal to 10, okay, I have a number n is equal to 10 and I want to find out all the elements who are less than 10 and are prime numbers. Can you tell me how many prime numbers are there less than 10? This is the series in front of you. I know that, okay, 2 is a prime number. I know that 3 is a prime number. I know that 5 is a prime number. I know that 7 is a prime number. So for 10, the answer should be 2, 3, 5, 7. Makes sense. Right? 2, 3, 5, 7 print होना चाहिए मेरा. ठीक है? Makes sense to me. Okay. But for example, if I have a number that is 20, 20 के लिए क्या होना चाहिए? Again, 2, 3, 5, 7 तो हो गई क्योंकि वो 10 से नीचे था. And next I have 11, I have 13, I have 15, I have 17, and I have 19. So my answer should be 8, right? 8 numbers. I have 8 numbers. Now, if I want to write the code for it, what I can do is one से n तक loop चलाओ, हर एक number का prime factorization निकालो, and see, check if every number is prime or not. So it will really cost you a lot of time. Okay? It can take you to n square, it can take you to n cube, and it will just waste a lot of time. Okay? So the idea of sieve is very simple. A lot of people don't realize this. But what is the idea? You know the smallest integer, smallest prime number. What is the smallest prime number? You know that it's 2, right? So my sieve tells me, मेरा sieve कहती है, I'm given a question that is n is equal to 50. ठीक है, n is equal to 50. मुझे इससे नीचे सारे prime numbers निकालना है. ठीक है. So what do you do is you create a number, you create an array. Array मत बनाओ, no problem. I plus plus you can do anything. You just create an array of 50 elements. Second, 2 is a prime number. You just remove it. But now can you tell me जितने numbers 2 से divisible हैं वो सारे prime नहीं होंगे? Am I wrong or am I right? Any number now divisible by 2, I'm sorry if I marked 15 previously, right? I'm telling you that if 2 is a prime number, लेकिन 2 के multiples prime नहीं होंगे, right? So I'm using orange to denote the numbers which are not prime. ठीक है? I'm using orange to denote the numbers which are not prime. So 2 के बाद कौन कौन से numbers prime नहीं होंगे? Every number that is divisible by 2. That means this row, sorry, this column, this column, this column, and this column. It gets eliminated, right? We just eliminated 24 numbers. 50 में से सिर्फ 24 number बचे अब. Now I have to see this. Now I increase my count, I go to 3. 3 is a prime number, I know that. But all the multiples of 3, they won't be prime numbers, right? Every multiple of 3 won't be prime numbers. I'm sorry, I didn't know this. 3 is a prime number. उसका multiple क्या होंगे? 6, 9, 12, 15, 19, 20, 21. Then I have 27. Then I have 33. Then I have 39. And then I have 45. Okay, my table looks lot more sparse now. Okay. Now you go to the next unmarked number. Now you come to 4, and 4 पे if you are storing a boolean value then it's okay. Boolean value अगर false कर दिया है तो इसका मतलब वो prime number नहीं है. So now I come to 4. I see कि ये तो orange marked है. That means it is not a prime number. So I go to the next element 5. 5 अभी तक mark नहीं हुआ. That means it is my prime number, right? Because we also know that and the computer also knows that. So 5 के जितने multiples होंगे that won't be prime numbers, right? 5 के मल्टीपल्स कौन से गए? 35, 25 एंड ये वाली रो तो जा ही चुकी है 5 की, राइट? डज दैट मेक सेंस? ओके, नेक्स्ट आई एम कमिंग टू 6. 6 is already marked as orange, so I know it is not a prime number, so I'll just move forward. Next I mark 7. 7 is not marked, so it means it is a prime number, so I will mark all the multiples of 7 as not prime. 7 2s are 14. 14 is already marked. 7 3 is 21, it's already marked. 7 4 is 28. 28 is already marked, and 7 5 is 35, it's already marked, and 7 6 is 42, it's already marked, and 7 7 is a 49 should be marked now. Now next I come to 8, I go to 9, दोनों marked हैं, इसका मतलब prime नहीं है वो. I will go to 10, prime नहीं है. 11 is prime, right? So 11 के जितने भी elements है I will eliminate it. ठीक है, it's already eliminated. Now I'll go to 13, ठीक? I'll go to 17, I'll go to 19. Now can you see the numbers which are remaining? जितने बचे हुए हैं, they are all prime. If I mark them with yellow, can you see जितने बचे हैं मेरे पास, they are all prime, right? Does that make sense? So what we did, like I told you कि what is the work of a sieve? छलनी का काम करता है. You just filter something out of that, and this is what you get as answer. Cool. This is the whole idea of sieve of prime factorization, the sieve that you should be using. Okay, you can just go over the internet and learn about it. Now Russian peasant algorithm is really a very simple algorithm. We'll just cover it in 5 minutes. Russian algorithm, peasant algorithm states that for a number A, for example, there is a number A, okay, and you have to multiply two numbers. I have a number A 5 and number B 7. Multiplication कितना होगा A star B 35, ठीक है. But if my question, this is a very famous interview question, if you would like to know, you have to multiply two numbers without using multiplication, addition, subtraction, or any sign. Without using any sign, any operator. मतलब जो normal operator होते हैं, you are only allowed to use bitwise operators. Okay, how would you do that? The answer is simple. It's Russian peasant algorithm. It's nothing. If A star B, I can write A star B as 2A divided by 2A into B by 2. Can I write it as this? Multiply and divide by 2. Can I write it as this? मतलब इसमें कोई error होगा? I don't think so. There will be any error in this. Like you just multiply by 2 and divide by 2. This is as simple as it gets, right? So Russian peasant algorithm uses this idea. You increase the first number, you keep on increasing the first number, and you keep on decreasing the second number. You keep on doubling the first number, keep on dividing the second number till you get 1. ठीक है? जब तक division से 1 नहीं आ जाता, you just keep on doing it. And now you might think कि divide by 2 करना, multiply by 2 करना, ये तो allowed ही नहीं है. I mean, I told you, right? Multiplication and addition is not allowed. How do you do divide by 2 and multiply by 2 using bitwise operators? I told you just at the start of the session. Which operator, which bitwise operators can be used for multiplying by 2 and dividing by 2? So for multiplying, Akash is right. For multiplying by 2, multiplying by 2, left shift operator you can use, right? Left shift operator. And for dividing by 2, you can use right shift operator, right? Does that make sense? So in exams, I remember this was a question in my exam that you have to multiply two numbers without using plus or minus. And I was really confused ki karna kaise, but this is something that everyone should know. Okay, let's just, if you want to see its code, I will just Russian peasant. I'm sorry, this file is just let me write it in .cpp. Okay, if I want to write the code, what would I do? I'll just take two numbers. Okay, and I want a number A as 20 and int B is equal to 12. So let's just write इसका code. I told you B जब तक 1 नहीं, B जब तक 0 से बड़ा है तब तक चलाओ उसको. And you have to multiply by 1 should be, A should be multiplied by 2, B should be divided by 2. Okay. Now there is one more thing that you need to keep in mind. If it is odd, what if the number is odd? What if B को तो divide करना है 2 से, लेकिन odd में तो क्या whatever, I mean odd में decimal आ जाएगा. So if B and 1, this is just a way to check अगर B 0 है, I mean sorry B odd है, ठीक है? Int result is equal to 0 since I want my answer to be result. So what you do is, in that case, you just write it res is equal to res plus A. You just add an instance of A. अगर B कभी भी odd हुआ, ठीक है? This is just your simple Russian peasant algorithm and nothing more. You just should know this idea कि bitwise operators का काम कैसे use हो सकता है. Okay? So just a second. Okay, I hope this was very clear to you today. The Bitwise, I have shared the document with you. You can practice more questions. Please make sure to practice more and more questions on Bitwise and maths because this is a topic many people ignore. But again, I told you, companies don't ignore this topic. So I'll just push it to the terminal itself so you can see it over there. And I'll find it. Okay. So
We'll be right back. Don't worry. In the meantime, you can see the code and analyze it and put the doubts in the live chat.
okay, so this was everything that was needed for bitwise operators and mathematics. I know it might be a lot tough for some of you because, come on, let's face it, that's a bit set and bitwise operators. But again, if you are interested in knowing more, you can just try bit masking. It is a concept used in dynamic programming. Okay, and you can just try learning about that. And bit masking is a very important concept that is used in dynamic programming, but since it is not beginner friendly, I would say, so you can just go on the internet and search. The document I shared with you, it contains many resources and the questions. Some of a link, a medium link over there contains about 50 questions related to Bitset, 50 questions related to binary uh, operations and everything. So you can just go over there and see. So any questions, you can drop any questions over here about mathematics, about computer science, about um, anything that you would like to know about CS, about maths, about bit manipulation, about data structures. You can just ask anything if there are any questions. I'll just check on my phone. Memorization, dynamic program, how to go with open source. Okay, open source. So open source is not a topic relevant today, but that's okay. You can. It would take a bit of time to explain about open source, so you can just contact me on my LinkedIn and ask about open source over there. And I know for beginners, open source can be really tough. It was tough for me also. It still is sometimes, but it's okay. Yeah, DP. Codeflow has a DP session coming up since they mentioned in the comment also that Navdeep Sandhu sir will be teaching it. But you use plus. I didn't use it to multiply two numbers, right? Can you share your experience and your project? Uh, Again, please hit me up on LinkedIn for these. You can just contact me LinkedIn on LinkedIn. Okay. Thank you, Suman. And since the session is about to close now, I would like to thank Codeflow. Like, I'm really sorry I couldn't see their message earlier on LinkedIn, and they contacted me. They reached out to me for this amazing um project. And the DSA bootcamp is really, really interesting with one of my favorite teachers coming soon. If you know about Mr. Abdul Bari sir, he's going to be there this month also. So he's going to teach backtracking, I guess. And we have had two of the amazing teachers in the past 2 days. We have sessions like every alternate day. And so I would like you all to tune in every day. It was today's session was on bit masking and bit manipulation and mathematics. The next of these next sessions would be on advanced topics also like backtracking, graphs, and everything. So if you are looking forward to learning a lot and learning a lot, gaining a lot of resources, because come on, let's face it, the people who are going to teach you, they will of course tell you the roadmap ahead, the questions ahead. So you can just go over there and check it. For any questions you have, I understand that not all questions can be asked today. And for example, if you are solving the questions from the question list and you're having any questions, you can feel free to reach me out on LinkedIn. It isn't like I just taught you today and I just have my part done. You can just contact me on LinkedIn and you can just send the question. You can send your doubts. You can send any questions which you want. Okay. And I would like to thank Pragya because she was like when I was like really nervous and she was the person I was talking to, and it was quite interesting. And also to Hargun and Vaibhav because they would have been a great contact point for me. And also the person who reached out to me on LinkedIn, I guess her name is Priyanshi. I'm not good with names, but then again, thank you all for joining in, and
Thank
I
you,
hope.
ma'am, for such a great session. Like, I enjoyed it. I was learning the whole time. I was more
I,
engrossed in learning
I
than
could
of
see your, I could see your expression, and you were like this, and I was like, okay, okay, oh, good, she is learning too, and I was like, wow, that's interesting. So so if any questions, ma'am, please reply. Plus, I told you, thanks for such a great session. Thank you so much. If you have any questions, uh, the if loop, yes. Whenever an odd number is made and with one, the answer is always one because since last bit of odd number is always one, you know. That's why it is just a way to check if a number is odd or even. And please, you guys should also thank Codeflow and Pragya Vaibhav and every person associated with this because they're bringing something really, really good. When I was in my first year, second year, come on, I needed such things. All I was doing was I was just, I was like, ये book पढ़ लो, वो book पढ़ लो, इसके बाद चले जाओ, उसके बाद चले जाओ, and at the end, I ended up learning nothing. So it's like I needed these opportunities. I wish this was when I was in my first or second year, but it's okay. I'm not crying.
Thank you for providing us with these opportunities.
Yeah. Also, there is, if you want more of such resources, I have a lot of them. Just contact me on my LinkedIn or just ask me up for any topic you want. Because, when I was learning, when I was in my second year, I was learning all of these things. So I collected a lot of resources. So I have a treasure of them. So if you have any topic requirement, you want learning resources, you want questions, you can just ask me.
Thanks a lot, ma'am. Thanks a lot.
Okay, so I think so you can take leave because it was a heavy session. And let's go and eat some food.
Yeah, sure. Thank you.
Okay, so yeah, bye bye. It was nice meeting you and nice
Bye
meeting
bye.
everyone.
Good